All right, we're on to the back now of Unit 1, end of course review. So flipping over, we'll start looking at exponential models first. So exponential models, yeah, this is just a mess here. Sorry, we're missing a x up here also, so if you'll fix that. The form of an exponential model is y equals a times b to the x. A is the initial amount, so that's however much you started with. Maybe it's money in a bank, maybe it's the amount of bacteria, maybe it's, we have a squirrel population in just a second. B is what you're multiplying by each time to get the next number. So the B is the multiple, what we say, that's what you're multiplying by, and then X is the amount of time, and that can be in years, months, days, it all depends on how the question is set up. All right, so looking at example number 9, your bank account starts out at $1 and triples every day. After how many days will you reach $1,000? So the deal here is that our initial amount is 1, because it's $1, and the multiple is it's tripling every day, which means that we need to multiply by 3. So the initial amount is $1, it's tripling each time, so the equation would be y equals 1 times 3 to the x. And we know that that 1 right now is not that important anymore because multiplying by 1 isn't going to affect our answer. So we could say that the equation is just 3 to the x. Now it says after how many days will you reach $1 million? I don't know, I might have said 1,000 a second ago, sorry. So that is going to be the amount. This is the y. So we want this to be $1 million. So 3 to the x. We want to know what does x have to be in order for 3 to the x to be $1 million. And what we did when we were back in Unit 1 is we just did some guess and check. So let's just throw out 3 to the 20th. So if you go to your calculator and you enter 3 to the 20th, let me put it under the screen here, I got something really, really big. So let's tone it down. How about 3 to the 10th? All right, that's a little more reasonable, but I'm below. So let's try 3 to the 15th. All right, we're getting better, but now we're over again, because if you look for decimals here, we're a little bit over. So let's try 3 to the 12th. All right, that's under. 3 to the 13th. We're just narrowing it down. All right, this brings us over. So 12 days wasn't enough, so we need 13 days in order to have $1 million, if the money is tripling every day, which is actually pretty incredible. So X is the time, and we decided that it would be 13 days. Okay, sorry for the pause in the video. Someone came and knocked on the door. All right, let's move on to example number 10. The number of squirrels in a forest doubles every week. Currently, there are 2,000 squirrels. How many squirrels will there be in 18 weeks? So information we know, the A is our initial amount, and there are 2,000 squirrels starting off. B is the multiple, and it says it doubles every week, which means times 2. And then X is the time, and it says 18 weeks. So X is going to be 18. So the equation will be y equals 2,000 times 2 to the 18th. So then you can go to your calculator to figure out this one. And this one is not a guess and check because we have everything we need, the variables on the left. So we need to do 2,000 parentheses 2 to the 18th. Okay, let's see. Okay, looks like 524,288,000 squirrels. And that is a lot of squirrels. So again, you have other options to do. You could do 2 to the 18th. You get that answer, multiply that by 2,000 to get your answer. You could do 2,000 times 2 to the 18th. That one should be okay. But just be careful when you do the problem, and as always, I would probably do each problem twice. Okay, that takes us through exponential models, and we're going to touch base with that again because we did more with exponential.